doing the problems. So I did the code for comparing grades last week. But basically, what you do is you create a scanner, and then you have two variables, and you set the first variable equal to the first number, and then the second variable like as the second number, and then you compare the two using the operators that we learned last week, which would be like greater than, less than, etc. And then you use that to determine whether the first one's greater than or less than the second one. And then the second question is says that you want to find the class average of her 5 students, and so you have 5 students, and then you want to find the average of those students. And so for this problem, what we're going to do is we're going to first create a scanner. We're going to read it from system.in, and then we're going to create 5 grades. So grade 1 is equal to in.nextInt. And so what that does is it takes the cursor from here, the very beginning, to after the number 92. And so what we can do is we just do that for each one of these in.nextInt, and just takes all the integers from the input file. We do this 5 times. 3, 4, 5. And then you guys can, like, this is how I would do it. Instead of like you can print it directly, but like in case you want to use the average later on, if you have like a more complicated question, just create a double called average, and that's equal to G1 plus G2 plus G3 plus G4 plus G5, and then we divide by 5. But because all of these are integers, in order for it to typecast to a double, you need to divide by a double. So you divide by 5.0. Or you can typecast one of these numbers as a double, such as putting double in front of the G1. So all of those like methods work, but regardless, when you're dividing, at least one of them has to be a double in order for it to be a double in the end. Then what we can do is we can print ln average. And then when we run this code, it works, and then we can submit it. And yeah, so both of the test cases work. And then the last one, extra credit, you basically, let's see. So you want to give extra credit to the students, and the formula to calculate how much extra credit each student gets, you average the scores, and then you average that number with the score of each student and divide it by 10. So for example, for Andrew, the extra credit he would get, the way you calculate it is you would average all 5 of these students' grades, and then average that with 39, and then divide that by 10. And then obviously the sample output you'll see is you end up getting 4.2. And so for this problem, we create a scanner, and we see we have 5 people. So we can do string name1 is equal to in.next, and then we have string int score1 is equal to in.nextInt, and then we can do this for each one of the 5 students. And this one would be N2, S2, N3, S3, N4, S4, and 5. And then what you want to do is you want to first find the average of all the scores. And so that would be the same as the last question. So you do double average is equal to score 1 plus score 2. And then you add all the scores together, and you divide by 5.0. And then you want to output the name of each student followed by how much extra credit they get. So what we can do is we can first system.out.println. So we want N1, which would be the name of the first person, in which case here is Andrew. Then we want to add a space. And then we want to find the extra credit, in which case would be the average plus the score of the first student divided by 2. and then you want to divide it by 10 because the problem states that you divide it by 10 at the end. So instead of dividing by 2, we divide by 20. And then we can like first see what this code outputs, and you'll see that your output is correct for the first one. So you know that everything above this is correct. And so we can just do the same for each one of the students. So we can do N2, N3, N4, N5, S2, S3, S4, S5. And if we run this code, we'll see it works for the first test case, and then if we submit it, it works for both. Are there any questions about last week's problem set? All right. Let's see. Now we'll go on to this week's topic, which is control structures. And so basically what control structures are they're like ways to change the path a program goes. So when you write a program, you'll see that it follows a very step-by-step kind of instruction set, right? So you just have a list of things you want them to do, and then the program just goes through that list and does them one by one, right? And control structure lets you alter and like modify the path that the program decides to do. There are 3 different kinds that we're going to look at today. The first one is the conditional branch. And so that would be if you want to have like an option to do 2 different things. Like for example, if you say, if the score of a student is greater than 100, then you do something. But if it's not greater than 100, then you do another thing. In that case, you would use a conditional branch, which we have, which today we'll actually focus on just 2. We'll focus on if and like if else and switch. So those are the 2 we're going to look at. And then the second type of control structure we're going to look at is called a loop. And what loops do is it allows you to do something over and over again, so you don't need to like constantly copy paste your code. So for example, that last problem I did where I like had to copy paste that system.out.println multiple times, a loop would actually make that a lot easier, because then you can just have it the program repeat a certain line of code multiple times rather than you copying and pasting it. And there are 3 we're going to look at. They're the for loops, the while loops, and the do while loops. And they both have their own, they all have their own kind of unique aspects that make them easier like to implement in certain cases. And then the last control structure we're going to look at is called a branching statement. And those let you kind of alter the flow of control in loops. And what that means is you're able to skip certain parts of the code that you don't want to happen without needing to use like an if-else statement. And I'll kind of go into that a bit later. But these are the 3 kind of structures we're going to look at today. So the first one, conditional branches. The most basic one is called the if-else statement. And the way it works is that you put if, and then you put the condition that you want to be met inside parentheses, and then you would put what happens if those conditions are met. And so the way you would use it is you would use an if and an else statement. So we'll look at an example code. Okay, so this is how you're supposed to write an if-else statement. These 3 lines, or the first 4 lines, is a simple if statement. So you have 2 integers, a and b, and you say if, and in parentheses, you put the condition, you put a is greater than b. And a greater than b is, remember last week we learned about operators, this would return true because 5 is greater than 3. So if this statement inside the parentheses is true, then the following code inside of these curly brackets would then output. So then you would put if a is greater than 5 and 5 is greater than 3, if a is greater than b and 5 is greater than 3, you would system.out.println a is greater than b, right? And so this is the most basic, the first 4 lines would be the most basic if statements. But oftentimes there are multiple cases that we need to look at. And so we would have else if and else statements as well. And so we would put them all together, and we would have if a is greater than b, then you would do this system.out.println. Else if a is less than b, you would do this print line instead. And then finally at the very end, you would put else, you would do this. And so the first line in an if else like kind of chain should always be an if, and then everything in the middle should be like an else if. And then finally, if you want an else statement at the bottom, you can also put an else. And so for this code, if a was 2 and b was 3, it would first look at this if statement, and a would be 2, which is less than 3. So the first if statement turns out to be false. So it skips this line of code, so it doesn't output it. And then it goes on to this if else if statement, and it sees that 2 is less than 3, and so it outputs this. And so it then ignores everything underneath it, right? And so that's why you would use if and else if statements. And then finally, another thing you should look at is that the reason why we have else if statements is so that you don't run multiple if statements. So for example, if you have this as an if statement, and let's see if I can get a good example. So if we have A is greater than or equal to B, and then we have this, well, and let's say this was 3. If you had an if statement here, what it would do, it would look at this if statement, and 3 is greater than or equal to 3, and so you would output this line of code, right? And then it would go into this next statement because there's no else if, and it would read it and it sees A is equal to B, and so it would output this as well, right? But if you only want to output one line, then you would use an else if statement, like for example here. And then what it would do is it would read the first if statement and it's true, and so it would only output this first line. Does that make sense? Are there any questions so far? Okay. I'm going to change these back. Okay, so this is how you use if-else statements. It's probably the most basic kind of control structure you'll look at, and it's really useful when you do later problems. And then the second type of conditional branch is going to call the switch statement. And switch allows you, if you have multiple cases, you can, it's just easier to code and it's easier to write out and it looks a lot neater. So what you would do is you would put switch and in parentheses, you choose which one of the cases you want to look at. So in this case, we want to look at count, determine what count is. So if count in this case is 0, then it would output count is equal to 0. And if count was equal to 1, it would output count is equal to 1. Otherwise, if it's neither of these cases, it goes to default and it says count is negative or greater than 1. So this is just a bunch of if-else statements, but in a more compact manner, and it looks a lot nicer and makes your code a lot neater. And then you'll see these kind of break statements. And the reason why we have these break statements is so that if count, if let's say count was 0 and it goes to case 0, if you don't have this break statement, then it continues to go through all the cases. And if it satisfies another case, it also does that. And so what you want to do, or like, for example, the default one, it would output this. And so what you want to do is you want to put a break after each one of your cases. So that way, after it outputs what's inside of this case, it would break out of this switch statement and just skip the rest of it. Okay. Are there any questions about this? All right. And so if-else statements use the structures or the operators that we looked at last week, like greater than, less than, two equals to, or 2 equal signs, and like those kind of operators, right? And then there are a couple of other operators that are also useful when using like if-else statements. And there are these 3. So you have the 2 and signs, the 2 vertical lines, and a caret. And the 2 and signs is called a logical and. And so what that does is it returns true if this operation and this operation are both true. So if you have 5 is equal to 3, which is false, and 2 is equal to 2, which is true, you have false and true. And because not both of them are true, you would output false instead. And so you could use an if statement with this code and it would output false. And so it makes your if-else statements a lot more complicated and you can do a lot more things with these kind of operators. The 2 vertical lines is called the logical or. And basically, if at least one of the statements in the operation is true, then it outputs true. And so in this case, like in the same case, if you have 5 is equal to 3, which is false, and 2 is equal to 2, which is true, then at least one of them is true, so the output ends up being true. And then the last one, this caret, is called the logical XOR. So it's kind of similar to the 2 vertical lines, the logical OR, except for only one of them can be true. And if both of them are true, then it outputs false. So in this case, only 2 is equal to 2, so it would output true. But if you have 3 is equal to 3, and you have a caret, and then 2 is equal to 2, it would output false. because because both of them are true. And actually the caret name is called bitwise XOR. But yeah, so these are the three Boolean operators you should like remember when using if-else statements and other kind of control structures. Okay. And then some like when you get into deeper problems, you might have multiple of these Boolean operators. So you might have like A is greater than B and A is less than 3, or B is greater than 2, for example, right? And so you need to make sure you know exactly which ones you want to do first. And so there's a precedence chart that shows exactly which one goes before which one. And so the ones at the top are kind of the things that we looked at, where it's like I++, which is an operation to increase a variable. And then you have multiplication, addition. But the ones you should look at are exclusive OR, which would be the caret, the logical and then the logical OR. So these three, like the one with the most priority is the bitwise OR, and then it would be the logical and then the logical OR, or the bitwise XOR. So it would be the caret, the and signs, and then the vertical lines as precedents. And we'll look at an example of that. So if we look at this code, the first line, we have 5 is equal to 3, which is false, and 2 is equal to 2, which is true. And because this is an and sign, and not both of these are true, you would output false. The second one is the same, except for it's the OR, it's the logical OR. And because at least one of them is true, you would output true. For the third one, because it's a caret and only one of these statements is true and not both of them, you would also output true. And then you can also use parentheses to signify precedence. So in this case, what you would do is you would first look at 5 equal to 3 or 3 is equal to 2. And because neither of these are equal, this first statement is false. And then you look at the second statement, 5 is greater than 2, so this is true. And you have false and true, which ends up being false because not both of the statements are true. And then finally, if you look at this one, you'll see that we first look at the and signs and then the or signs, we first look at the and operator and then we look at the or operator, because and has a greater precedence than the or. So we have 5 is equal to 3 and 2 is equal to 2, but because not both of these are true, this ends up being false. And then you finally have 5 is greater than 2, which is true. So you have false or true, which gives you true because at least one of them is true. Okay. So that's basically the conditional statements. It's probably this is probably one of the most used control structures you guys will end up using. So I highly recommend you guys learn at least if-else statements. The switch statements are not as useful because it's just a way to clean up your code. But be sure to memorize the if-else kind of format because it's going to be really useful. And then the next one is loops. Next control structure is loops. And so basically, what loops are is it continues a set of instructions over and over again until something is, or until a Boolean expression is set to false. And we'll look at a bunch of different a bunch of different loops. And each one of these have like different use cases. The first one we'll look at is called the for loop, and it lets us repeat an operation and by incrementing a variable and evaluating a loop counter. And so the syntax for the loop is you have a for statement, so you put for. You have the initialization, a Boolean expression, which is what you want to check in order to make the loop stop, and then a step case. And we'll look at exactly what this means in a second. But for most cases, after you put the for initialization, you put curly brackets and then you put the statements inside of the curly brackets. But if you only have one statement, you don't actually need the curly brackets. But that's just something, it's like a technical thing you guys should remember, that if you have multiple statements that you want to be put in a control structure, like an if-else statement or a for loop, then you want to put curly brackets. But if there's only one statement that you want to use or that you want to execute, then you don't need the curly brackets. So an example would be for int I is equal to 0, I is less than 5, I++. And so we'll take a look at each one of these steps. If we look at the syntax, the initialization would be the int I is equal to 0. So this would be initializing like a variable. Most people use I, so I used it in this case, and you set that equal to something. And most people start at 0. So I put int I starts at 0. The Boolean expression is what you want to evaluate in order for the for loop to stop. So in this case, for example, we want to stop when I is no longer less than 5. And then finally, we have the step. And what the step does is it does the incrementation. And so after each for loop, you would increase I by 1. So if we look at this code, we have I is equal to 0 at first, and then we go through the loop. And since because I is less than 5 already, we output I, which in which case is 0. And then at the very end, we go back and we increment I by 1. So now I is equal to 1. And then we see I is still less than 5. And so we output I, which is 1. And then we go back and we increment it again. And so the incrementation happens at the very end. And then you check to make sure you satisfy the Boolean expression before you go into the for loop again. And so the output in this case, you would output 0, 1, 2, 3. And then at 4, when I is equal to 4, 4 is less than 5. So you would output it. But then when you increase it by 1, it becomes 5. And then you check the Boolean expression. 5 is no longer less than 5. And so you break out of the loop and you continue the code, or you continue the program, what's under the code. So this for loop lets you do like a fixed number of steps. So for example, if you know that you have 10 students and you want to do the same thing for each one of those students, you would do a for loop from 0 to I is less than 10, and it would do the same code 10 times. The second type of for loop that we're going to look at is called the enhanced for loop. And this is something that we'll look at more deeply next week when we go, or the following weeks when we go over arrays. But basically, if you have basically an array or a collection is just a bunch of different variables of the same type, or a bunch of data types of the same type, put into like a container. And so it lets you like use a bunch of variables without needing to initialize like a bunch of them. And there's a way to use a for loop that goes through each of the items in an array. But we'll actually look at this a bit more in later weeks when we actually go over arrays, because it's not very useful right now. And then the third type that we're going to look at is called the while loop. And the while loop lets you use, or like lets you repeat a set of actions like an unspecified number of times while the Boolean expression is true. So while the for loop has a set number, so you would set it like to loop 10 times, a while loop will loop until the Boolean expression is set to true. So the syntax would be while, and then in parentheses you put the Boolean expression, and then you put the statements. And so an example would be while I is less than 5, then you want to you would output while loop I is equal to I, and then you would increase I. So this is actually like kind of similar to a for loop in the sense that we're initializing a variable and we're increasing I while I is less than 5. And actually, the output isn't just the numbers. There's going to be like a bunch of text in front of it. But for this case, let's just say that it only outputs I. And so if we look at this problem, we see that int I starts at 0. And we check the while loop, we check the Boolean, and it says I is less than 5. And so we do output I, which is 0. And then we increase I by 1. So now I becomes 1. And then we go back and we check the Boolean again. And we see that 1 is in fact still less than 5. So we output 1. And then we do that over and over again until I is 4. We output 4 and we increase that I by 1. So it gets 5. And then 5 is no longer less than 5. So it breaks out of this while loop and continues the program. And so while obviously this one is also very similar to a for loop because we have like an int I is equal to 0, this inside Boolean expression can be anything you want. So you could be like, while like something is greater than 5, you continue to do like you like do something else, and it would be a lot like more flexible than a simple for loop. And then the last loop we're going to look at is called a do while loop. And a do while loop is basically the exact same as a while loop, except for while the while loop does the Boolean expression or checks the Boolean expression at the very beginning of the loop, the do while loop does it at the very end. And so if we look at an example here, if we have I is equal to 3, we would first do the statement. So we would output I gives us 3, increase I by 1, so I becomes 4, and then we check the Boolean expression I is less than 2. So even though the initial I already does not satisfy the Boolean expression, because do while loop does the Boolean check after the first iteration of the loop, you're still going to end up outputting I, because it still ends up doing these instructions. Okay, are there any questions about loop so far? And of course, all of this is on the drive, so you guys can always go back and look at the syntax and how to create it. And the more practice you guys do, the easier it'll be to write these kind of control structures. Okay, and then the last structure we're going to look at is basically break and continue, and we use these with loops in order to change the path that the program is taking. And so we would use the word break if we want to break out of that loop completely, and then we would use continue if we want to skip the rest of the loop that we're in and just go on to the next loop. So these are two examples of how we would use break and continue. We would use an if statement with a break and an if statement with the continue. And if you look at the break example, for example, we see that it's a for loop that goes from 0 to 100 and it outputs everything from 0 to 100. But we have an if statement here that says that if I is equal to 5, then we want to break out of this loop. So what ends up happening is we have 0, 1, 2, 3, 4, 5. And then when we get I is equal to 5, we first output 5 because of the system.out.println. And then we look at this if statement and we see that because I is equal to 5, we break out of this loop and we don't continue anything else. So the 6 through 99, all of that gets skipped because of this break statement. And so this is really useful if you only want to do a loop up until a certain point. And then after that, you just want to completely break out of the loop and not do it anymore. And then this one is the continue. And so what continue does is it skips the current iteration and it goes on to the next loop. So if we look at this case, we see the sum starts at 0 and I starts at 0. And so we go through let's just go through each one of these iterations. We start with I is equal to 0. And because I is not equal to 4, we don't do this continue statement. So we add 0 to sum, so we end up still getting 0. And then I becomes 1. 1 is not equal to 4, so we skip this if statement. And we add 1 to the sum, so now the sum is equal to 1. And then you do the same thing with 2. So if you add 2, you get 3. And then when you get to 4, when I is equal to 4, when I is equal to 3, you add 3, so you get 6. And then when I is equal to 4, what it does is it looks at this if statement, and because I is equal to 4, we can continue by skipping the rest of the commands inside of this for loop and just going on to the next loop. So we don't actually end up doing this sum plus equals I because of this continue statement. So we don't add 4 to sum, and our sum ends up still being 6 at the end. And then we set I is equal to 5, and because I is not equal to 4, we don't do this if statement. We add 5 to the sum, so we end up getting 11 because you just add 1 plus 2 plus 3 plus 5. And so this is also very useful if, like, for certain cases, you just don't want to do the rest of the code and you don't want to put a bunch of if statements that end up making your code really messy. Because if you wanted to skip the rest of this code, you would do another if statement that says, if I is not equal to 4, then you would do this. And after you do a lot more like complicated questions, that can make your code really messy. So continue just kind of cleans up your code and makes it much easier to understand. So those are the main kind of control structures we're going to look at today. I'm going to send you guys the link to the practice problems for this week. And it's we'll have like 8 minutes. I'll do the first question at around 2:22, and then I'll go over the rest of the questions next week. So let me pull up the link for